Hello students, I welcome all of you to the Let's Practice session. So in this session, we will take a chemistry problems and solve this chemistry problem by understanding the concept behind it. So let's see what is today's practice problem. In organic chemistry practical, solubility of organic compounds are very important factor. In this video, I am going to discuss the solubility of different organic compounds and how it can be decided from their functional groups. Here we have taken few organic compounds and we will check their solubility in aqueous sodium hydroxide or hydrochloric acid solution. Cyclohexanol contain alcoholic OH. Alcoholic OH is not acidic enough that it can react with sodium hydroxide solution. That means cyclohexanol is insoluble in sodium hydroxide solution. Similarly, it is also not soluble in hydrochloric acid solution. This is cyclohexane carboxylic acid. Cyclohexane carboxylic acid is an acid. That means it can react with a base like sodium hydroxide. It will form sodium salt of carboxylic acid, and that's why cyclohexane carboxylic acid is soluble in sodium hydroxide solution, but it is not soluble in HCl solution. Next, compound is nitrobenzene. Nitrobenzene is a neutral compound. That's why it is not soluble in sodium hydroxide or hydrochloric acid solution. This is called acetanilide. Acetanilide, this nitrogen has lone pair, but this lone pair take part in the resonance. So that's why it is a very weak base. Since it is a very weak base, so it is partially soluble in hydrochloric acid solution. You may have to heat it in hydrochloric acid solution, then it can be soluble because it is a very weak base. Next compound is 4-dimethylaminophenol. We know that phenolic OH is stronger acidic than alcoholic OH but weaker acidic than carboxylic acid. So we can use sodium hydroxide solution. It will form sodium phenoxide and it will be soluble in sodium hydroxide solution. Next compound is 3-aminophenol. Amino is basic in nature because nitrogen has lone pair. So if I add hydrochloric acid, 3-aminophenol will be soluble. So it will form salt of ammonium salt. So it is soluble in hydrochloric acid solution. Now phenolic OH is acidic in character. So if I add sodium hydroxide solution, it will be soluble in sodium hydroxide by formation of sodium phenoxide. That means 3-aminophenol soluble both in hydrochloric acid and sodium hydroxide solution. Now toluene. Toluene is a hydrocarbon. So since it is a hydrocarbon, so it is neutral in nature. So it is not soluble in hydrochloric acid or sodium hydroxide solution. Next compound is 4-nitroaniline. In the 4-nitroaniline, again NH2 is basic in character. So if we add hydrochloric acid solution here, it will dissolve in hydrochloric acid because it will form ammonium salt as I have discussed in 3-aminophenol. So 4-nitroaniline is soluble in hydrochloric acid solution.